Welcome back to PageKey. Time for another broadcast. So, really having trouble getting past this VGA stuff, but got to keep pushing here and see if we can get through it. Where we left off, I was having trouble with the font stuff. After I stopped yesterday, I kept poking around a little bit and have a few things to show. But first, Paul Weirman left a comment on the last video, which I thought was really helpful. He probably also was in the live chat, but for some reason I can't get the live set up. I don't know. But anyway, Paul left this comment. It makes a lot of sense, so I appreciate that. Okay, I think I'm set here. Anyway, yeah, thanks, Paul. So he's talking about the memory being interleaved. I think this makes a lot of sense. And he says, well, get rid of the copying the fonts check. I thought I commented this out. Oh, I have to pull. That's why. So, yeah, I commented that out because that was a little messy. And that's good advice. Returning to text mode, need to restore the panes 0 and 1 and make sure the correct font is selected. Plane 0 is the characters, plane 1 is the color or attributes. That all makes sense. For some reason I'm getting mixed up changing the font. But let's take a look at what I was able to. It is if you look here, sorry, this is a little slow. Can't wait to finish up with this and make a video about this so I can stop just streaming about it all the time. But for the record, here's where we're at. If you run VGA and go back, now, if you type this font thing and see the character set, I made a few changes here. The A character has been changed. The appearance of the A, the B, and this, actually that's the @ sign. So the @ sign, the A, and the B have all been turned into this vertical bar. And the C has some interesting stuff going on there too. It's been corrupted a little bit. What's the code that's doing that? So, I mean, the important part is I figured out where these characters are, and I've been able to change them around. So the @ sign, if I change this piece of memory, you know, if I write 2 bytes to that part of memory, it or actually the repeating, if I write F0 repeating to that memory location, we get that vertical bar. Same for A, B, and C. So I found where the ASCII character sets are in memory. It's at 0xb8000 plus 0x2000. So that I thought was interesting. And if we can edit the character set like that, then we should be able to restore it as well. But yes, so in theory, but also in theory, we should be able to copy the entirety of B8000 all the way out and then copy it back in and be fine. But that doesn't seem to be happening. So I think I'm just going to go back to toying around with that register value for CRTC that seemed to mess things up. So let's see what that does with this. Actually, was that not it? Okay. Okay, interesting. Was there something with the sequencer too? Maybe not. So far so good. The max scan line, can I just set all of these or will that mess things up? Interesting. Why does this seem to this seems to behave differently every time I use it? I don't know. Granted, it's not the most scientific approach, but can't seem to nail this down for some reason. Interesting, interesting. So, all right, what if we do our little clear screen? We plot some pixels. Well, I don't want to use that clear screen method. Let's just memset B8000 to 0 for the first 100 bytes. And see if we can get a little black part of the screen there. Yes, that worked, and we can restore back, no problem. But if we clear the whole screen, are we saving memory? I forget. We are, yes, we are mem copying 0xb8000 to that place, a lot of it, and then we're copying it back afterward, right here. So at what point does mem set start causing problems? I think it's around 0x. That's still okay. Yeah, it looks good. Yeah, so I see someone's watching. Thanks for watching. I don't know if my chat's working right, so if you say something, I'm not intentionally ignoring you. Okay, 1,000. So we can go at 1,000 as well, and the prompt prints all over the screen, and we come back, and we're fine. I'm wondering, is it... If this just, all right, I don't even want to say it. Let's keep poking around. So we clear the whole screen, and we can get back, but now we're starting to lose the font. So we lost, what did we lose here? We lost the special characters. So we lost the beginning of the we lost the beginning of the alphanumeric, whatever, ASCII. So if we do, instead of 2,000, we do 3FFF. Is that a happy medium? No, we lose everything in that case. I guess that's a lot larger. Yeah, it's a way bigger number. But 2,000's okay, and it clears the whole screen. And it just messes up some of the fonts. So, VGA font. So, we definitely lost some stuff. What if, and this is not really fixing the problem, but what if we just did 1,500? And... we still have everything. Doesn't clear quite the whole screen. And we already lost the exclamation point. So if we go 2,000, we lose all the fonts. We lose most of the fonts. If we go 3FFF, we lose everything. Yep, we are in the dark. So, what if when we go back, we set up these fonts the same way that we were before? In fact, I could probably just move this down here, and it would have the same effect. So let's do that. So when we get back out and we restore the memory, we're going to set these fonts. Still doesn't work. What's going on there? That is nuts. Is my memcpy not able to handle something that large? I really just about had enough of this. So if I push just a little further until that A gets erased, which I think might be right around that point. We still have the A. Let's go a little further. Still have the A. Keep going. Very close. Maybe 2 more. Okay. That's interesting. The letters that I'm setting actually seem to be staying. A, B, and then the... Oh, wow, look at that. Look at that. C. C almost disappeared. The parts of C that I did not edit disappeared. Am I restoring? No, I'm not even restoring it. I'm just... This is after I set it to 0, though. So if I move this down here, does it still do that? Or do I have to do it prior to restoring text mode memory? Oh, that's really weird. Ah, that's really confusing and weird. Wonder, okay, so let's go back. So this does restore these pieces. So, but that, why? Why? Okay. So, if I do it after this, it doesn't work. What if I get rid of that? Nothing. Huh. This, my mind's blown. I'm so confused. So confused. And then we get that. Whew. What is happening? Is this memcopy wrong? I'm pretty sure... Wow. Is there like a size limit to the move SB thing? The old AI guy. Yeah, we're not worried about that yet. Okay. This all looks right. Why in the world would restoring text mode video memory, which should be overwriting this stuff, why would that work? Is this 10B8000 not... Maybe I should move that 1 up a little bit. How many? 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6, 7, 8. 100B8000. Let's see if we can copy it to there. Like maybe we're hitting it. Or would it work the same? 10B8000, 100B8000. Okay. Blank. if I restore it back, it'll work. Partially works. So it has to do with where I'm copying this to as well. How do I know like where it's okay to use some memory? Can I change this to an F? Then what? That's the only instance of that. So if I change that to an F, I mean, in theory, it shouldn't matter where in upper memory I'm copying this to, right? That wipes it too. This is insanity. How do I know where I'm allowed to copy to? This is nuts. I'm going to ask ChatGPT, and then maybe I'll Google it. What memory locations are free to use on an i36 system? Non-reserved. Question mark. I need memory addresses. Okay. I must be doing something wrong here. This is insanity. So I was going to 10B8000, which A00 to okay. I'm not using the BIOS. Extended memory. Free for use if it exists. So it's possible that that doesn't exist up there. So this is what I got. Oh, I guess 10 1B8000. So maybe I should do 1B8000. Maybe I'm going just a little too far out of memory. Let's try that. Let's try 0 here, 1B8000. And we'll see if that even works. Is it really like a magic number that we're copying to 10B8000? That's just insanity. Just insanity. So that works too. But we do lose some of the font. But we're able to copy back in some of the font, which is nice. So I think we have something here that could work. Let's look up the ASCII font list. How many characters are there? I'm not sure. But if we go 0, the @ sign is 64. There's only 255, right? Okay. So, whatever. Let's start by seeing if we can restore the A character using this method. I don't care if it's right. I just care if it works. So, somehow all this CRTC stuff is still working. So, so the A character's here. Why would it not just save it when we do this step? Why would it not save and restore? That's what's really confusing to me. What if I restore after we switch into the sequencer as well? Like right here? Ooh, that's funny. What? I literally just copied the same memory back. But something must be getting messed up with the sequencer or the CRTC. It just infuriates me, dude. Why? Why? I'm getting a little too worked up here, but this is insanity. Not sure what to do with this. So we clear all the memory. Does not appear to get restored properly. Some of it does. But if I get rid of all this, nothing gets corrupted. It does still. So I'm just tempted to try saving the character A somewhere. So can I memcpy this to $10 B8000, because up here we're using 1 B8000, right? Yeah, so I'm wasting huge amounts of memory, but who cares? 10 B8000, I'm going to put the character A there. So 10 B8000 plus 0x2000. I'm going to copy 0x B8000 plus 2000. And what else do I need? Oh, how many characters? Yeah, 80. Which is 128 bits for one character. So I'm going to copy that way up into high memory. And then what if I mem set it right back? Does it restore the character? Like, what's going on here? Let's just copy that out for now. Or does it restore the @ sign, I guess, in this case? No. We lose the character C. And the character D. What if we also do that guy? Right. Oh man, I don't know what's going on here, but let's see. D, are we going to see D corrupted? Yes. So how do we get back to not corrupting everything? We should stop clearing the screen so intensely. I forgot a semicolon, didn't I? No. Okay. So this doesn't lose any characters, I don't think. Actually, it did lose a few. Lost the exclamation point. And we accidentally, I seem to have corrupted the E and not the D. Fair enough. Okay. So what are we going to make of this? Very confused. We're able to corrupt characters, but if they get wiped, they're gone for good. I think what I'm really struggling with is how do we save things into memory? I mean, it says it's free for use, but I'm copying stuff up there and it's getting wiped. So I don't know. Maybe there's another device that's modifying the same memory as I am. I don't know. Maybe, yeah, okay. Maybe I need to read a little bit about this on osdev.org because they're always good. Okay, that's pretty simple. That makes sense. Oh, it looks like an A. Okay. So this is a byte, right? 1, 2, 3, 4, 5, 6, 7, 8. What if we... Can I turn the C into an A by doing this? That is the question. So will this turn into an A if I paste all these in? 2, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Oh, this is a pain. But we'll get there. 12, 13, 14, 15 are the same. Okay. Will that turn C's into A's? If we go back, no, that does not work. Okay. Does that work if I somehow stop corrupting things? What's even going on with this? Very confusing. Yeah, the C is not corrupted the way I thought it would be. What if I stop corrupting any of these characters? And the D. Just the C character. What did I do wrong? Did I only get half of it? That does not look like an A. So if I get rid of this, surely the C looks normal again. Yeah, the C looks normal now. So if I... This should just affect the A, right? If I do the A. Back to square one here. Yes, that just affects the A. Instead of F0, if I make it FF, what happens? it turns into a block of nothing. And if I do the same for C, I should just get a block as well. That does perfectly corrupt A and C. So, is that the right address for C? Oh yeah, it is. Okay. So if we write that many bytes, or decimal, yeah. So we're writing 128 bytes. Shouldn't it be, what is it, 128? So it should really be 16. Why does it take so much? Because surely this isn't bits, this operand. This is bytes, right? So it should really be, how many bits in a byte? It's 8, right? So it should be that, and that should corrupt the C. Like I don't see why I have to do so much. That only does the top piece. Why? Maybe that's a key here. Maybe that's a piece of the puzzle. So if we just set that first one to FF, that first char, you don't even see anything. What if we do it again? You also don't see anything. Is this not the right way to set a memory address? Maybe? Okay, finally, we start to see something. So maybe I'm off a little bit here. Maybe it doesn't start until that address. Because that is the first line. Do we get 2 lines if I do the next one? No, I do not. I have to do it again and again. 2 looks the same. Do I get another line if I do it again? No. So is this interleaved on like 8s? That would kind of make sense. So that has 2 lines. 6. That seems so random. Okay, so the second line hit there. What if I turn all the other ones to 0 until I see... I think the 3 and the 6 were where the lines came in, right? So if those other ones don't make a difference, or they're part of something else, then this should have 2 lines still. It does. Okay. So, oh, you know what's, I think, so maybe this is plain, this is font 1, this is font 2, this is font 3, this is font 4. That could be it. Oh, that would be so annoying. And maybe we're not supposed to, oh. Brigitte Ianti took back your message. Okay, I missed it. Sorry. I didn't see what you said. So the character All right, so character C. This is confusing. So to get the start of the character, we need to be 2 more bytes. So we'll do +2 here, and that's going to give us the character C's start address. Okay, so let's just figure out what this is, because we can figure this out. And then we're going to test the theory here. We're going to test our theory that, so if we add those together, can we put that next? So BA182, that is my theory. That is where the character C lives. BA182. And we should be able to set this first one to FF and get a line. And then this is font 2, font 3, font 4, and then this should become another line. So I really just shifted it over 2. So we should have 2 lines at the top of C. Let's see if that happens. We have 2 lines, yes. Okay, we're getting somewhere. This makes sense. So that's why it takes so many characters. So we have to write 4 bytes to hit all 4 interleaved fonts. I think that's what's going on. So if we want to define C, or actually this is the letter A, right? So I think we can do what we were trying to do before now with a definition of letter A. So it's going to be I forget how to declare that. Like that, right? 128 bytes. Can I do this? I don't know. Yes, I can. Can I do this? Yes. Okay, good. So actually it doesn't need to be 128. It needs to be 128 bits, which is 16 bytes. So we just need 16 bytes, and then we'll have our character. So I'm going to ask ChatGPT to do this work. Can you turn this into the following format? 0. Or no, just okay. That was helpful. Thanks, ChatGPT. Have a nice day. Thanks. Have a nice day. Okay. So if we throw this, all right, whoa. All right, so if we throw these in here, we should have a definition for character A. Can you change it to / for that comment? Let's see if it figures that out. Yeah, nice. It's good prompting. Wow, 6 people are watching? What is up? Where are you people? Say something. How's it going? Okay. That's our letter A. Thanks, OS Dev Wiki. Now, if we want to set the character C to the character A, we'll start at this address, and we will loop through I to 16. Ooh, I made this way too big. It's only 16. I++. And we're going to use the same technique here where we set all 4 memory planes, all 4 fonts. That's my theory is why it's like that. So we'll set all 4 fonts to, say I +1, I+2, I+3. No. I times I times 4 plus 1, right? Because we're striping it with these 4. So we're going to say and we're going to set it to letter A of I. I think that makes sense. So we're going to stripe all these. Really, we only need to do this first one, but it's nice to set all of them, I guess. Maybe not. So in theory, that should copy letter A into C. Whoa! That is so ugly. It's okay to share ChatGPT documents? Yeah, I mean, this is all open source, so I think it's fine. What meaning description byte 1 to 15? So, okay, yeah, so I got this stuff from, I got the VGA fonts description on os.org, osdev.org has this, and it's telling you that this is the letter A, and you can actually see that it's just painting a letter A. So that's where I got that from. And then I needed it to be in the right format to paste into the C code. So I just told ChatGPT to put it in that format. So it did the translation from that other format into valid C code. So that's what's going on there. Yeah, so theory did not work out because that is really, well, it kind of looks like an A. It's a little ugly, but it almost came out. Maybe that's actually how it's supposed to look. Actually, I think it is. Oh, you know what? I think ChatGPT messed it up. Yeah. It totally messed it up. What the heck? Come on, ChatGPT. That's not right. That's really funny. Yo, translate this right. That looks better. Let's take that. It was dreaming there. It was hallucinating. Alright, so that looks correct. Maybe a little right shifted or something. But let's try that. Okay, yeah, it's a little downshifted, but it did work. We were able to replace the C character. I can't really hit. Hey, Paul. Working on glyphs? Glyphs are in ROM. Read-only memory? Okay, yes. First of all, thank you for your comment yesterday. I tried my best to understand it and apply it. And yes, I'm working on... I don't know. I just can't get this font to restore. So I'm playing with font because I can't figure out how to get it to come back after I go into VGA mode. It's really killing me. I have no clue what's going on with it, but at least I'm actually going to commit this because we were able to get the A character up, which was interesting at least. But yeah, Paul, it sounds like you probably know a lot more about this than I do, so totally open to any wisdom you may have here, because I'm feeling around in the dark here. So create letter A in code. Also, I think there's a delay with the stream, so it might take a while for me to answer. But yeah, Paul, I appreciate your help. Ugh, I don't know if I can do too much more of this. Where the print assign block pixels? I don't know where the print assigns block pixels. So the print method, all that it's doing is copying into video memory. So it's just putting the character into video memory at a certain position. It accepts a character and puts it into 0xb8000 plus a certain offset. And then I guess it doesn't really do anything with the color. Maybe that's it. Maybe my print... Oh, wow. Maybe my print line is not putting any color and it's getting wiped. Oh my goodness. That's it. Brigida Yanti. Sorry if I said that wrong. I think you're totally right. So I need to find out about that VGA attribute bit. Because can we change the color just by changing that second thing? If we can figure out how to do that, then I think it's just getting set to black, which is why we can't see anything when it comes back. So, right? So let's try breaking at VGA info maybe. VGA info. And then I'm going to edit. How do I edit memory in GDB? I forget. How do I change memory in GDB? I can set. Set. Okay, so examine. B8000 as a string. So yeah, there's a \A. So examine character. B8000 is the dash. 8001 is \A. What is that as hex? 0x07. How to print pixel address and memory address registers. Pixel address and memory address registers. I don't know. Pixel address. So the pixel addresses I haven't figured out yet, because that's when we get into graphics mode. I don't know. Maybe it's, I'm sure it's something to do with the VGA card, but your guess is as good as mine. So a character. What if I set it to 8? Is that the wrong syntax? Oh yeah, I forgot the equals. Okay. So if I continue, it prints so much stuff that it doesn't even... Alright, let's change the print function to actually provide the... yeah, so, but I really think you got it here. I think you just told me the answer. Thank you. Screen, print char at, is this what the print line's using? Print line just says print. Print just says print char. Print char says print char at. Print char at says do the offset. So we set the character, but what we should also do is, can we do like pointer offset +1? Equals 0x07, and then that should have no effect if that's even valid code. So that looks okay. Now, would the color of everything change if I change this to an 8? That's my question. Yes! Yes, it does. So it looks like I'm not using print char at all the time. But if I go into VGA, come back. Okay. What register functions available VGA and where memory address assign at? So for VGA, so VGA has all these little subsystems. I don't know what they're actually called. Maybe if Paul's still watching, I feel like he probably knows a lot more than me about this stuff. But from what I know about VGA, video memory for one of the planes starts at B8000. I don't know. I would recommend just going to this website because it explains it really well. I think I can put this in the chat. VGA docs. Ooh, it's not letting me type. VGA docs. All right, I pasted it in the chat. Yeah, I pasted that in chat. So yeah, I've been using this extensively, and like all these little subsystems like CRTC. I think the main one, if you're starting with this stuff, is to check out the graphics controller, because that's where you can change the text mode and all that stuff. Yeah, no problem. Here, let me paste this actually. Start with this one. But this whole website has a lot of good info. So, but yeah, the graphics one. So basically, there's the address register and the data register. And if you output something to you use the I/O port out to the address register first. So you set register to that address port with where you want to change. Hold on, this probably isn't making any sense. This set reg and get reg kind of shows how you do it, but like you get the register value, the current one at the address port, because you don't want to like overwrite if someone else is using it in an interrupt routine or something. You output the address that you want to write to, and then you either read data, in this case you're reading the data, and then return it, and then restore the register, or you select the address using the address register, and then you output data to the data register. So I don't know, I probably butchered that explanation, but maybe it helps. I don't know what I'm doing here, but I think you did help me solve this issue of, I can't believe it. I can't believe I was so lazy that I didn't set the background, and I was just assuming it would always be there. So that might be it. So if we restore the memory, does it work now? I'm very excited to see if that is the case. What data that output at data register? So it varies, but like the address register, you're going to put one of these values for the address register, right? And then after that, what you output to the data register, or you can get the current value, is these things. So like the actual value you want to set the fields to. So an example of that is like right here, we get all the current values of the graphics controller registers, and then we get the register miscellaneous, which is this one right here. So we get the value of that, and then we change something about it. In this case, we're ORing this to 1, and then we just like output the data back to that port, is my understanding. Those definitions for VGA planes aren't meaningful. The planes cannot be directly accessed like that. Yeah, so, oh, actually it's on the screen right now. So the reason that I think I'm maybe getting the terminology mixed up then, because these came right from here. So maybe the planes are actually interleaved, whereas these memory maps are just like which memory section, but like all of them within them have 4 planes that are interleaved, 1 2 3 0 1 2 3. Maybe that's the case. I don't know. I'm fully open to feedback on that. Brigida Yanti, which port is meaning? So I'm not sure what you're asking. Which port is meaning? I don't understand. Can you rephrase the question? We come back. So if we clear, I think I commented out where we're clearing the screen. Is that it? This time? No, it's still messed up. We still lost most of our text. Only the ones that I corrupted. The output is memory address with port. Those are regions that are mapped to video memory. Okay, so they're just regions. Just regions, got it. Let me rename that then. Actually, this isn't even used anywhere. How about this? No. How about this? That was used all over the place. This isn't even used. Oh, wow. Oh, well, this is nonsense. I'm just going to delete all this. Plane 2. This is a mess. I'm just going to change this back to VGA address. And then, well, maybe I don't have to delete them. I can just call it region 0, region 1, region 2, region 3. So thanks. Thanks. Yeah, that makes sense, Paul. Appreciate it. And then Brigitte, the output is memory address with port. B quad 0 is used in monochrome mode. B 8000 is used for color text mode and graphics mode. Okay, that makes a lot of sense. I keep reading about monochrome mode. But yeah, I didn't really know what the deal was with that. Okay, that's interesting, because I know you have to do the IO address select thing to make sure whether you're in monochrome or color mode. What's the difference between VGA address and region? Well, this VGA address is one of the regions. These are the same, but I know that B8000 works, so I'm just going to use that as my VGA address. But Paul was just saying that these are regions, not whatever. But these are just places where the VGA card is mapping its memory into a place that the CPU can read and write it. So it's memory mapped IO to the card, right? Is how I think it's working. So so what's going on here? So actually, let me just stop corrupting the pixels for the poor font. Let's not corrupt the C. Let's not corrupt the A. And then on exit, we copy everything back. Same up here. So thank goodness it's not something wrong with my memcpy. It's so bare bones anyway, I don't know what could be wrong with it. So this is great. Everything that's white text is getting wiped because it's all getting the color bit wiped. I don't know what's happening in my less than sign or my greater than sign, but the fact that most of the text is sticking around is making me happy. And that's good progress. I don't know what happened to some of those characters though. Maybe I don't know. There's still some problems here, but we're getting closer. We can get halfway back without messing everything up. So that was a great insight. The fact that we're not setting the background byte. I'm going to keep it as this dark gray color. Actually, what other colors do we have to deal with? It's kind of cool. Woohoo! Wow, that looks so cool. Alright, I'm definitely sticking with that. So we lost the A? We lose half of our characters. So is memory map correlate buffer address? Memory map correlate to buffer address. I don't think... Well, actually, I guess that might correlate, right? Because a memory buffer is just a section of memory. I'm not too sure. And then, Paul, you said, the plain concept is internal to the VGA card. Nice to know, but not useful programming it. Oh. Okay, so that's... Well, okay. Hey, if I don't have to know about it, all the better. I'll forget I even knew anything about planes because there's enough to know to get this thing to work. So if it doesn't matter for programming it, that's all I care about. But that makes sense that it's like an internal thing. So if I hit enter in VGA mode, I get all this pretty printing going on. Because I'm doing that. And then it turns green, which is weird. And then it copies it back. So this is better. This is definitely better. I might stop for tonight. How long has this been? An hour? Yeah, I might stop soon, but the background color thing was a great insight. I gotta think about what else is getting corrupted here. Maybe, are we copying? We're not copying enough, maybe? 3F, F, F is not enough? Or like what else could be going on here? Are we clearing too much of the screen? Like here? I guess we can go back and work our way up to it again and see what happens. So that clears, that screws stuff up. 1500 probably doesn't clear the whole screen, but we keep our font, right? VGA font looks good. How to VGA address path to drive vendor. Oh, so like how do you figure out the card vendor or the drive vendor? So like how do you figure out who made the card? I'm not sure. I did a past video on making an LSPCI command and I didn't get too far, but I think, at least in this case, the VGA card is card vendor, yeah. Driver vendor. Oh, I see what you're saying, yeah. Yeah, so I know that this card is what it is because the i386 docs for and driver workflow. Yeah, so I don't know, I've been trying to research this. QEMU tells you right here that their i386 system has this exact card, so I cheated. I didn't actually figure out which card. It just told you. I didn't detect it. And then the manual is online for that exact card, so you can read the technical manual for the card. And these links are on GitLab if you need them, or I can send them in the chat if you want. VGA is a standard. All VGA vendors meet. Okay. Okay, perfect. Yeah, so maybe we don't even care what card it is. That's great. Yeah, that's a lot easier than trying to detect it, I would think. But yeah, I mean, I know some VGA cards are PCI, so maybe you can detect it with LSPCI. Other ones, I don't know. But yeah. So I can't really do exclamations. I don't have a shift key. Okay, well, let's see. What else can we do today, if anything? At what point does it really get messy? At what point does it get rid of our characters? Still have all the characters. Oh, we lost the exclamation point. Is that between 15 and 17? We have an exclamation. Oh, we have the asterisk. We have a lot of stuff. And then we lose the exclamation point, and that's it. I don't get how we're losing characters. That's really stymieing me. How to register and activate VGA. Is there a specified register? And how to see details of the VGA. Vendors are free to extend the spec with new features if you care to use them. Okay, that's cool. Yeah, I think I saw some in the technical manual for this card that are like extra features, which is interesting. Like there's a video record feature in here somewhere. It's pretty crazy. And then Brigitte, you said how to activate, which register to activate VGA. Is there a specified register? And how to see the details of VGA. So that's what I've been trying to figure out with this stuff. It's not one register, it's a bunch of different registers. And I think when you boot the system up, you're already going to have VGA active, or at least that's the case for this, because I just started writing before I even started messing with the VGA driver. I was able to just write to 0xb8000 to put text on the screen. So like your firmware might pre-initialize it, I guess is what's happening there, and set up VGA to be displaying properly in text mode. And then what I'm trying to do now is modify the VGA registers in such a way that we get into graphics mode so that we can draw some pretty pictures. But I'm having a seriously difficult time doing it, which is why I've been doing this same stream for the past 6 days trying to get VGA working. So I don't know if that answers your question, but yeah. So, oh, okay, so drawing the pixels works. I'm gonna try copying more stuff, saving more memory, which is not the best solution. So instead of 3F, let's do F. And then we'll restore that many as well. So like maybe I'm just not saving enough. So right now, did we lose the exclamation point? We did. No, VGA font. We lost the exclamation point. Let's see if this saves us our exclamation point back. VGA font, VGA. No, we still lose the exclamation point. That is crazy. What are CRTC functions? The CRTC is the cathode array tube controller. It's one of the sets of registers you can modify for it. If you, whatever. CRTC docs. I'm just going to send it in the chat. And then the BIOS inits the video card to color text mode. Okay, I forgot that we do. Yeah, the BIOS runs before we get to this point, and then the multi-boot loader too. And then yeah, that makes sense. Good call, Paul. You're definitely right. So it puts in color text mode. I'm curious about monochrome text mode now. I'd love to see if it looks different, but I can't deviate from this path. I have to figure out what's going wrong here. So I want to keep clearing the screen and just see how many characters I retain when we get to, first of all, we'll go back to 3FF, because that did not help. And then, yeah, Paul, I don't know if you've ever run into this. I don't know if you've worked with VGA a lot, but I am stumped as far as why we're losing characters of the font, unless it's also related to the coloring of the background like it was before. But, alright, so now I lost some stuff for sure. VGA info is looking rough. Looks like I lost the numbers. Yeah, I have no numbers, or no, I don't have zeros. Curve font. Yeah, I lost some pretty important numbers. 0 and 1 are pretty important. But I mean, there's a lot more left, it looks like. So I'm kind of hopeful maybe I can make it to the bottom of the screen and still have some kind of usable text interface. Yeah, I mean, we made it to the bottom of the screen and we still have our alphabet. It's actually not bad. And the top part went away. So like, where is that PKOS part coming from? I forget. Like, I might not be using the print functions for that. And that could be the problem. Print, PKOS, print char with ASM. Alright, anywhere that I'm using print char with ASM, I gotta change that. Arguments. I only left that in there as just like to show how you do it, but we gotta consolidate here. Oh, nice. That looks nice. But see, we still lost half of our stuff. Are we not copying the color bits? Are we not backing up the color bits? That's crazy. I don't know what's happening. How workflow to key press and change pixel. What memset conjunction with ASCII? 3 parameters of memset memory address map. Memset memory address map. Okay. So I think your question is, how am I currently changing things when I hit keys, maybe, or like how once I'm in VGA mode would I set up key drivers or something. So I have a video on the keyboard driver that we did, which is a pretty basic one, but there's a fair amount of like pick setup, programmable interface chip, I think. But you have to init the interrupt table for your CPU, and then I'm fuzzy on the details here, but there's some good comments in here. But yeah, you set up your interrupt table, and then you can handle your interrupts by using the pick data ports, whatever. I don't know what's going on. I kind of forget this whole thing, but yeah, it's all in this kernel.c file, which is probably not ideal. And then you said the memset stuff. So the memset is in this memory.asm and also in this H file. And it's just like I copied the C memset like format, and then all it's doing is the x86 instruction set has this move SB and this store SB. So it's like a repeated byte or rep, whatever. So like you just fill these registers with the right values, and then you call that, and it copies, either it moves in this case, or it copies a certain value into a memory address. So like basically memcpy and memset are imported, or they're implemented like at the hardware level for i386. So you just have to plug it in the right way to the hardware. That I'm sure that's not the case for like ARM, right, or for reduced instruction set stuff, but sure is nice. Good old CISC, right? But yeah, what else? I'm basically out of things here to try, so I might commit and call it a win for getting at least half the screen to show back up. So I think what we did was just set the color bit in screen.c. So yo, Jonathan, thanks. You the man. All right, I'm just gonna say shit is no joke. I agree. I can't figure this out. This is crazy stuff. I don't know what's going on with all this, but with the help of Paul and others, maybe we can get there. But this commit's just gonna say set color / attribute byte when printing text, and that solved at least some of our problems. Dude, you're trying on the side? Oh, seriously? That's pretty cool. Is it like, are you documenting it with videos, or like, is it open source? Because like maybe we could do some kind of collab or work together on this, because I would love to work on this with somebody. Provide any insight you can, but def the lead right now. Oh, okay, well, I'll try my best. Yeah, let's put our heads together, because this stuff, especially this VGA stuff, is really, I really don't know what to do, but I might have to sleep on it. But like, I'm just kind of stuck here as far as how the font's getting destroyed. Paul, I don't know if Paul's still on, but Paul, you said earlier that ROM is where the glyphs are. So like, how do we copy this stuff back out of the ROM? Or is it just printing black on black text? And because that's what was happening for at least half this stuff, but it's just so inconsistent. Like, and I have a feeling that it's great that we were able to clear this screen with these ultra long pixels, but like pixels, so that they're nice little square things that we can actually draw with. It's going to be a big problem. We're going to lose all of our font if we lost part of it already. So it will be open source. My goal hasn't changed a lot. I want access to a pixel buffer, and that's it. Hey, I feel you, because like once you have that, then you're set, right? You can do anything if you can draw to the screen. And then like, I'm thinking if you have access to a hard drive too, then like you don't really have to deal too much with hardware. You can go so far with it. That's why it's so exciting, but it's so hard. Yeah, we're at the same place. Cool. Oh man, it's just so hard to get over this hump of making this work. Hmm. Wow. Well, I don't know. Jonathan Strength. Dude, keep in touch. If you're not on the Discord, let's meet on there and like chat about this, because I'd love to have somebody to work on this with. I'm getting stuck working on it by myself. When the color square pixel matrix coordinate location or memory. Where color square pixel matrix coordinate location or memory address? I have no idea. So much others. Yes, exactly. Yeah, please keep in touch. Yeah, it's all about like making something you can see happen. So that's why it's so exciting. But Brigette Yanti, I don't know. I think maybe there's registers location at screen. So like the only way that I'm printing stuff right now, and you can see these 2 pixels here, it's all about just like where in memory you put it, and it's just laid out like this is 0xb8000 at the top left, and then it goes up, and then when it reaches the end of the screen it wraps around. But like I was just adding 320 because I think I was in a certain resolution that was 320 wide, so I would just add 320 stuff on the screen before, but it's not really currently working very well, so take that for what it's worth. All right. Oh wow, there's just so many people watching, and I'm just so out of, like 5 people are here. That's crazy to me. I don't know what else to do. I gotta give up for the night. We need a line of separation, font mode versus pixel mode. Grossly incomplete. Yeah, I mean, I wish I could just flip a bit and go back and forth. I don't know why it has to be so incredibly hard. Like we're programming like a CRT, but it's like 3 times removed backwards compatibility. But hey, nobody, I guess, said that OS stuff was easy. I guess the whole point is that it's hard. VESA drivers. Interesting. I don't know what like is VESA different than VGA, or is it like one of the older versions, or is it newer? Maybe that's the way to go. Whoa. Oh. Oh, see, that's nice. Look, we have the little square pixels. Oh, I see a couple little dots there. What in the world? Oh, whoa. Oh, wait, so I'm not even in... I see the cursor way up here, and then I see little pixels. So maybe if I restore the CRTC back to what it was, I won't get these little mini text guys. So, whoa! With the color bit, this is telling, because I'm just hitting enter. What if I type VGA info? VGA info. Clear. What happened? Now I have nothing. VGA. So it's putting these little tiny dots for the text, so we must not even be in text mode. So I'm messing something up here. But I could have swore I was putting it back into alphanumeric disable down here somewhere. Yeah. Does anding to 0 set it to 0? Yes. Text mode. I don't know. Wow, 7 people watching. All right, we got to find something interesting to do here. VESA drivers. Okay, yeah, so it's totally different. Plot pixel, is there XY value or matrix address? So plotting pixels, you got to do your own XY. It's just a matter of how far into the memory plane you are. So 0xb8000 is the top corner, and then, yeah, just you got to do your own arithmetic to figure out how far into the memory zone you go to get your X and Y. So I did it here under the assumption that we're on a certain resolution. Actually, it might work now. Yeah, I mean, you can kind of see the little pixels that I made. There's like the two tiny ones there. But I don't know if it's actually 320 across or not. But yeah, so once you init VESA, very hard to go back to VGA. Okay. Interesting. From 16 real mode. So I think I'm in protected mode. I don't know if that makes a difference. I kind of forgot about all that stuff. Probably the same deal though, right? You can't really reach back in. Yeah, I don't know. Another standard, but not all vendors implement it. Oh, okay. Interesting. Interesting. Yeah. Pixels grid resolution should be set or have been default. So the resolution, Paul or Jonathan may know, but I have no idea. It has to do something with how you're setting up the CRTC settings, and I guess like I've seen actually in OS 15 we dump in just preset values for the registers, and that's considered to be 320 pixels wide, 200 pixels tall, I guess, or maybe I got that backwards. 256 color bit depth, right? Or whatever. 256 colors. But it's just a bunch of registers. This is why I'm confused that it didn't work when I was just outputting all the registers before. But yeah. So it's just for looping through them. Actually, while we're looking at this, so we do the miscellaneous, we do the sequence to reg, CRTC. Lock 16 color palette. Attribute controller 20. I have no idea. I don't think there's actually a register that corresponds to the resolution. Brigida. Yeah. By the way, if you guys like this video or whatever, yeah, consider liking and subscribing. It would help a lot. And there is a Discord, so like when I end this stream, if you still want to talk, I think it's in the description for this stream, so you can just go to the Discord and we can chat about this stuff too. But super excited. There's actually some people watching. That's pretty cool. Yeah, I think I might stop. Sorry, there's 4 people, but I'm gonna have to wrap this up because I'm not making any progress here. I have no idea what to try next, but I think might look a little clearer in the morning. Or some other time. But yeah, thank you guys. Glad you tuned in. Jonathan, I'll be on the lookout. Let's keep in touch and work on this together, hopefully, and get over this VGA hump. I don't know. And yeah. Have a nice night, everybody. Yeah. Subscribe to PageKey if you're into it. Yeah. Thanks. See ya.